This is multiplying matrices. When defining a matrix, we define them as rows by columns. So in this matrix here, we can see that it has 2 rows and 3 columns. So we would define it as a 2 by 3 matrix. And when we're multiplying matrices, it is important to look at the number of rows and number of columns of each matrix. So for the first matrix A, we can see that it has 2 rows and 3 columns, and matrix B has 3 rows and 2 columns. And when we are multiplying the two, the requirement in order for us to be able to multiply them is for the columns of matrix A to be equal to the rows of matrix B. As we can see, since A has 3 columns and B has 3 rows, we are able to multiply them, and the resulting matrix is given by the dimensions of the numbers on the outside, which are 2 and 2, the rows of matrix A and the columns of matrix B. An important thing to note is that AB is not equal to BA, because if we were to reverse the order in which the matrices were multiplied, in this example here, instead of having a 2 by 2 matrix as the resulting matrix, we would instead have a 3 by 3. Our first example is to find AB. So in order to multiply a matrix, the simple rule is that you multiply the rows by columns based on the location of the entry. So since each matrix is a 2 by 2, the resulting matrix should be a 2 by 2, and we are able to multiply them because the columns of matrix A is equal to the rows of matrix B. Our first entry is given by row 1 and column 1. And what we do is very similar to finding a dot product, where it would become 1 times 3 plus 5 times 6, because this is the first row of matrix A and the first column of matrix B. Then we would look at the next entry, which would be located at row 1, column 2. So we would look at row 1 of matrix A and column 2 of matrix B, and from that we would get 1 times 2 added to 5 times 4. Then we would look at row 2 of matrix A and column 1 of matrix B, and it would become 7 times 3 plus 0 times 6. Lastly, it would be 7 times 2 and 0 times 4. Then with just some multiplication and addition, we should end up with 33, 22, 27, and 14. Find ED. So let's look at the dimensions of both matrices. And we get that E is a 3 by 2 matrix and matrix D is a 2 by 3 matrix. So we know that since their columns of matrix E and the rows of matrix D are equal, we can multiply them, and the resulting matrix should be a 3 by 3 matrix. So again, we would look at row 1, column 1, and get 3 times 3 and 2 times 7, and we'd add those, and then we do the next thing for the next column of matrix D, 3 times 5 and 2 times 4, and then 3 times 8 and 2 times 12. Then we would look at the second row of matrix E, which would be 1 and 15, and then 1 times 3 plus 15 times 7, and we would repeat for the next column of D, and then the next column of D, and then the final row of E, 4 and 6, we would get 4 times 3 plus 6 times 7, and then 4 times 5, and then 6 times 4, and then the final row 3 and column 3, we would get 4 times 8 plus 6 times 12. And then we would find the answer to each entry, and this would be our resulting matrix. 23, 23, 48, 108, 65, 188, 54, 44, and 104.